Essentially, what I'm going to talk about today is I'll be introducing a little bit about cloud computing and serverless. So if you're already well versed in that, this might be a little bit boring to you, but it will be mostly kind of an introduction. But at least if you're already well versed in the cloud, you'll see a little bit about what EDF is about and how we do things at EDF. So as you can already see, I work for EDF. I am a software engineer at EDF. I work in the wholesale market services. So that's kind of the energy trading part of the business. I'll give you a little bit of an intro of what that part of the business is in a second. But we essentially trade energy so that we can get energy to our customers. So it's all, if you ever see one of those trading floors, maybe in finance, you'll also see the same in the energy industry. You've got a trading floor, a billion screens, alarms blaring. That's also the kind of applications that we make on the trading floor. Just before I get into Brighton into the workshop and the content, I'll just a little plug to the Data and Tech Graduate Scheme. If anyone here are students or anyone that's listening in, we have a really, really unique graduate scheme that I went through as well, and it kind of gives you all aspects of data and tech. But yeah, I'll skip over to at least my experience in the graduate scheme. So actually, I only started my tech career about 3 years ago. I did chemical engineering, and then I went straight into tech. I started off as a junior data scientist, junior software engineer, data engineer, DevOps engineer, and currently a software engineer. So as I said, it's a unique graduate scheme. It pretty much helps you in all aspects of tech. So from this, I know how to deal with data from a data science point of view, from a data engineer point of view. I know how to deploy applications from DevOps and also understand and create applications as a software engineer. Obviously, we know which one I love the most, hence I went down that route. So the reason I'm kind of introducing cloud computing to Python is because I feel like a lot of Python developers, sometimes we create applications and we're not actually that well versed in the cloud. So there are a few times where I've actually done this workshop with the University of Sussex a couple months ago. So we're actually going to be doing kind of the bare bones bit of it from Hack Sussex, which was a bit more of a longer workshop, and I had a lot more time. But I'm just going to talk through it and maybe even deploy it within 20 minutes or so. But just for some context, so I was speaking earlier about the wholesale markets. So if you don't know much about the energy markets, or it's always been in the news lately, so you might know a little bit more than what you used to. We essentially have generation and demand, and we want generation to equal demand, right? Otherwise, power lines will burn or we'll get blackouts, and it's a very intricate system. But then you've also got, as demand increases, then you have more expensive energy generators that come to life. Nuclear, maybe fossil fuels, renewables tend to be the cheaper option. So then you've got a market, supply, demand, and you've also got a fluctuating price, and therefore you've got a market. And with a market, then there will be buying and selling, which is what we do in wholesale market services. And we're kind of the glue. So as a supplier, we'll then have to take energy from the generators and get it to the customers somehow. Even when we have our own assets, we'll also be buying it through the market, but at a fair price. And this can be through various other exchanges like EPEX Spot or Nord Pool here on the right-hand side. So we don't need to go into detail on the timelines of things, but this is essentially just talking about how you can buy energy as far into the future as you like. So there's a base load. So we'll always know. So for example, I know that this is the amount of energy that will be consumed. Anything on top of that is what we call adding shape. And as we get closer, that's usually what it is. So this is our structure. So if you ever want to be a software engineer, I'll be putting the careers page after this. We are overhiring at WMS. We're trying to overhire because we're an expanding part of the business. This is where I sit. We support all the other parts of the business, of the wholesale markets business. So I was just these are just a couple case studies, but the real case study will be the one that we'll be talking about in the context of the serverless workshop. But these are just a case study just to talk about how we collate costs, and we need applications to essentially get costs from the market, market prices. We have a team called volume forecasting, which takes the forecasted volume. We have non-energy costs, and we try and collate them all. And we need applications like the one that I'm about to show you to feed that into the pricing team. So that sort of flow goes into the pricing team. And on this side, this is a national grid turndown. So if you may have been reading in the news about when you turn your electricity off at a certain amount of time, you can enroll into that and basically get some savings or some money from that. Those are just a couple examples. So the case study we're looking at is the net imbalance volume tool. So this is the serverless application that I'm going to be talking about. It's essentially the same supply and demand chart here on the right, but National Grid are responsible for keeping demand to equal generation, right? And as a supplier, we're responsible for keeping it balanced for our customers. And if we're a cause of an imbalance, you pay the penalty price. So for example, your generator might trip, or you buy too much electricity, or you don't have enough, then we basically pay the penalty price. And it's a trader's job, shift trader, 24/7, to always make sure that we are balanced. Hence, we have tools like this. And we can't trust the national grid's demand or supply forecasts, because they don't tend to be right, because we've got generators that always trip. So then we have to have our own forecasters and our own applications to deal with those sort of things. Hence, we have the volume forecasting team. But yeah, the traders operate 24/7. And the tool that we have is, unfortunately, I can't show you the full functioning tool because if there's any competitors in the room or watching on live stream, I'm not allowed to show our position. But yeah, there's lots of functionalities of the tool. It shows you a percentage of how long or short we are in the market. It shows you a tracker on the wind, a tracker on demand, a tracker on the interconnector screen. So interconnectors are, I'll get back to that. I'll get back to the interconnector bit in a second, but it's essentially the connections between countries. So we can actually buy and sell energy between that. So I was talking about a serverless application. So we tried to make this as serverless as possible. But obviously, we do have a lot of legacy systems. But the application essentially is hosted all on AWS. This is where the power of cloud computing comes in a little bit. We have a lot of Lambdas. Which are cloud functions, for those who don't know. So it's not really a typical application where you put it all into, say, you host everything all on your computer and then you deploy it onto a server. It's a lot more decoupled, and there are quite a few benefits on it that I'll touch in a second. But that's how we've approached the application. So there's a lot of queues and SNS, simple notification service, which essentially notifies the next part of the application. So there's quite a few benefits with decoupling applications. It helps with scalability, availability, and if something goes wrong, then you pretty much know where it is that you need to fix. So if this Lambda, for example, goes wrong, we'll pretty much get an error. So there's some observability. So we'll know we need to fix that Lambda. But that's pretty much a really good way to hedge yourselves with an application. So on here, we've got our own systems. So SDDT is our own system. We have a few databases that we pull in with a Lambda. We've also got an SNS queue, simple notification service. And we take that from sorry, I forgot the name for it, but it's a queue that one of our elects on, which is basically the body that oversees some of the trades. So there's a queue. I forgot the name of the queue. Yeah, but we take the data from there and we process that through the Lambda. and then through another queue. But this is where the core part of the application is. We've got data inside a Dynamo DB, which is a NoSQL database. We also put that data in an S3 bucket, but the recent data we keep in the Dynamo DB, you can think of it kind of like a caching system. And then we just have one API. So the design, you can have multiple APIs, but we've just kept it one because we're trying to keep it as simple as possible. We're only polling similar data. Data is separated by settlement periods, so we trade at a half-hour basis. So that's the NIV tool. This is an example of one of the screens. I know there's a lot to it, but the traders like it messy. They always like it messy. They like weird noises and just full of screens, full of charts. They want to fit as much as they can onto the screen. So sometimes if you think of UI stuff, you can, some of the stuff about CX, and that kind of all goes out through the door, because with the trader, you just want everything on the screen and that's it. That's why we don't pay attention too much on how it looks. It's always a fast-paced environment where we always want something out. But this is just the interconnector screen. So I was explaining earlier about interconnectors. So we want to know the flows of interconnectors, electricity flows between the countries. So I think we've got Belgium here. We have WD is within day and day ahead. So we'll know the forecasts, and also the current outturn of what's happening now. So for example, we've got outturn here for France, which is the blue dotted line of what's happening now, which explains why it's stopping here. So settlement 47, that's like the half hour that we are in at the moment. So not right now. I must have taken the screenshot at, wow, at 11:15. I was up late. But yeah, that's one of the screens for the NIV tool. Like I said earlier, high voltage cables to other countries. We can trade across the interconnectors. And now with this case study, I'm going to deploy a light version of this where we pretty much build a tool for the short-term trading team. It's completely serverless and it gives the live flows of electricities between the country. So just a light version of this screen without all this nice stuff. Well, messy stuff, but also just the chart. So this miniature application is pretty much going to do a few things. So there's quite a few ways that we can improve this, but we're just going to keep it simple for those who are a bit new. So we've got a Lambda here, a cloud function, which will have a token stored in the parameter store. And this is essentially for security. So we just store the token here. Well, I haven't encrypted it, but usually we'd accompany it with key management service encryption. And then that pulls from an API with that API token. Event Bridge is an AWS service which schedules that Lambda. So we'll schedule it for, I don't know, every 5 minutes, 1 minute. It depends on how often you think the data might come and how often you want to poll it. It'll then put it into a NoSQL database, the Dynamo DB. You'll also have another Lambda, which pulls from that Dynamo DB, and then an API gateway. So you'll create your own API so that can pull in data from the Lambda, which pulls it from the Dynamo DB. Where your front-end code will be hosted will be in an S3 bucket. So that's a storage bucket. You can pretty much store anything in S3. It's the most versatile part of AWS. You can put any sort of data files. It'll be a React front end. So the first time I created this, I knew this was going to be for a Python crowd. I did this as well for London Python. I'm actually one of the co-organizers for London Python. So if you ever come up to London, just join in on those meetups. But yeah, I tried to do PyScript because it was a London Python meetup, but it just was a disaster. And I don't think PyScript is as developed yet. But there was a few JavaScript concepts I had to integrate into making PyScript work. But I gave up in the end, and I just put React on there. And then we can front it with CloudFront. I can go into CloudFront a bit more detail later, but it's essentially a content delivery network. It's got quite a few advantages. You can link it to a domain name. When you are in a different country, for example, it can do some nice caching. You could associate web application firewalls with it. So it's just kind of something that you can think of that you would front your application with for various network reasons. But yeah, so not the best in terms of security, because we won't be applying some of the rules. So there's one of the rules as the rule of least privilege. So you always have to assign the least privilege. You won't see this in what I'm about to do, but we would typically we'd assign, for example, so this Lambda would have an IAM role, which is essentially a role that they assume that has the permissions of what they could do. So if they could access Dynamo DB, then we would only give it access to put stuff in there. But at this point, I've just given it access to everything, which is not good. If a hacker was ever to hack into my IAM role somehow, then he or she would have access to pretty much anything, if I've given it permissions to the whole system. So principles of least privilege. For those of you that don't know, what is serverless? So it's actually you still use servers. So it's not actually serverless. It's just that you just don't manage the servers. So you go over to AWS, you get a Lambda, a cloud function to do something with your application, but you don't actually manage the application. So you don't manage the server on the application. So for example, it's not like renting an EC2. An EC2 is like a server that you can rent that you could scale up and down on AWS. But that's pretty much what serverless means. I think I mentioned some of the advantages earlier about scalability, decoupling, so you know where the errors are. Sometimes observability, so it really depends on how you set this up. There are plenty of companies out there, actually third parties, who specialize in doing things like observability, like Dynatrace, who would pretty much can hook up to your AWS system and put it in a much nicer UI than AWS's UI. It's also a lot cheaper because you don't rent a server. So if you rent a server, it's not always being used. It's just a lot of processing time that you just don't use. But so you pay for what you use for. I think this is kind of a growing trend in everything in society, is we're only trying to use what we pay for. Right. So within the next 20 minutes or so, we can deploy the serverless application. This is not opening on my window, but yeah, I'm sure that's fine. All right, so I'm going to log into my AWS account. This is my personal AWS account, and it's on the free tier. So if you sign up for AWS, you have 12 months of free tier. That's essentially a certain amount of, it's not a quota, it's just you can use specific services for free. So usually, for example, Lambdas, S3 buckets, and all the basic stuff is usually for free. Yeah, so before I kind of get onto this, I was just going to say I am going to use infrastructure as code for some of this. And this is just so that I don't spend about an hour trying to build every single bit. But most of this will be built by infrastructure as code. So with infrastructure as code, it's sort of a really good best practice thing as well. So when you're, for example, when you're working for a company and you want to build something, say, I like to say DevOps should be its own role, but actually I feel like a lot of software engineers have started to assume the DevOps role. So all this kind of infrastructure as code is being adopted by a lot of software engineers now. I'm not saying the DevOps role is redundant. I'm just saying there's a lot more available out there for software engineers. So infrastructure as code is a best practice, and it's also something that makes things a lot easier. So whenever you deploy something onto the cloud, for example, sometimes if you want to have a few environments, development, pre-production and production environments, you won't always replicate it. you're a human, you're going to make some errors, you're going to mess up and not replicate exactly what you've done in development, for example. So then you've got infrastructure as code that will keep it completely consistent, and also it will be a best practice for you to manage. So for example, someone might say to me, oh, could you please add this new rule on this database? And all I have to do is change the code, and then the rest of my pipeline will take care of it for me. It'll deploy to development, pre-production, and production, right? So that's infrastructure as code. So my favorite is Terraform as infrastructure as code. Terraform is a cloud agnostic language. It's actually really, really simple. It's pretty much like a descriptive. You can pretty much just write. If you read a Terraform piece of code, you'll pretty much understand what exactly it's doing. It's just building resources for you. This here is CloudFormation. I did it in CloudFormation here, which is AWS's infrastructure as code, because when I did this workshop, people were doing it with me, and I wasn't able to set up permissions with Terraform to their AWS account. So it's best we just keep it simple, put it in a single YAML file, which can be uploaded to AWS. So what this infrastructure as code is doing is it's pretty much setting up the resources. So for example, here, I'm setting up that S3 bucket here. I'm also setting up the bucket policy. So that's the permissions behind the bucket. So again, the set of rules with an IAM, similar to an IAM role, but a bit more different, specific to the resource. I'm setting up the CloudFront, which is what I mentioned earlier about the content delivery network, SSM parameters. So it's usually just inputs like this. For example, here, property name, and so eAPI token. That's the API token that I'll be using to pull in something from the API. And that's just storing into the parameter store. So all this here is just defining what resource you want built. And so you don't have to waste your time into going to the console and building these things. And that will take some time for you. And also for the best practice elements that I mentioned earlier. So what I'm going to do is I'm going to go to CloudFormation and upload this YAML file. Last time I did this, my internet broke and we waited half an hour, but I'm sure it'll be fine. Right, so I've already got it saved here. I'm going to open that YAML file. So that was just the file I showed earlier. Click next. Let's call this Brighton Pi stack. So the token, there are options as well in IAC, in infrastructure as code, where you can put in inputs, and this is one of them. In CloudFormation, you can put the inputs like so. It's pretty much in the code. These are the tokens for the API. It's not that bad that I've shared them. It's not a security risk or anything. It's very public API. You just need to create an account for it. Going to create the bucket name and call it Brighton Pi 456. This is because S3 buckets need to be unique. You can't have a name that's not unique. I'll just keep that. Oh, and I'll click next. And nothing else needs to be. So now that's creating, what's going to happen here is it's going to create the resources. So CloudFormation, CloudFront will probably take the longest. So in the meantime, I'll just talk through the architecture again. In hindsight, I should have done this. I should have started it 5 minutes ago because we've already spoken through the architecture. But yeah, this Again, the CloudFormation will build this, but it won't have the code in it yet. We're going to do that manually. It's not going to build this because I want to show people how to create an API and how easy it is to do that if you've never done that before. It will create this, but it will not have the code in it yet. It will create this, but it's an empty database. The permissions will all be set in there. It will create the event bridge, but I haven't linked it yet with the Lambda. And it will create the parameter with what we've inputted earlier. And this is just the API, so that's not being created at all. But that's the infrastructure. And within the infrastructure as code, I'm going to see if there's a good example here on IAM roles. So here is the role. So this is the role, the set of permissions that I've set for that Lambda, for example. The Lambda, I guess I have followed the privilege a little, the least privilege rule a little bit. I've just allowed that Lambda to access that Dynamo DB table, so that NoSQL database. So that I've just defined the rules here in the infrastructure as code, and that will get deployed up in the CloudFormation in AWS. Right. Let's see what it has created. It's created the Lambda. I bet it's the CloudFormation because that takes a while. But if all of these are created, then no problem. We can go ahead and have a look at them. So I'm going to show you the Dynamo DB, for example. This should have created a table. Empty table. There you go. CloudFormation has created a table for you in interconnector data. Let's see, what else can we look at? We can have a look at the parameter store. We search parameter store. It's a lot simpler. So it's created the parameter for the ENSO-E API token. Under normal circumstances for security, we'd usually encrypt that, but we just leave it out there as a non-encrypted value. So since some of these resources are already built, we can continue, and I will paste in the code in the Lambda. So the first one is we want to be able to get data from ENSO-E, which is where we're getting the data from, which is a public API. And we're going to put it in the Dynamo DB. So this is what a Lambda looks like. It's got no code at the moment, well, it has code, but it's the default code, and that's how I left it. So I'm going to show you two different versions of putting code into a Lambda. The first version will be uploading through a zip file. The reason I did a zip file is sometimes you have packages that AWS doesn't have, and so therefore you need to package it up into a zip file so then you can input it as a package as well. And I had a very special package created by ENSO-E, so I put it into the zip file. Lambda.zip. It's 40 megabytes because I've packaged it up with the packages, the Python packages that come with it. Cool. So that's in there now, and I'm going to add a trigger. So we created an event bridge schedule earlier, so I can just add that on here and link it together. Brighton Pi, yeah, that's the one. So I scheduled the expression for 1 minute. So every 1 minute, it's going to activate this Lambda. If I test it, I don't need anything special in particular, so I'm just going to test. Fingers crossed this actually turns green, because this morning it did not, and I had to fix it. Oh, whilst we're waiting as well, let me show you the code. So everything that was in that zip file was actually, oh, it's disappeared. Where did I put it? Oh, the Python files disappeared. It used to be in this folder. But what it was essentially a Python code that pulled in from the API. I think I might have moved it because I needed to zip it up into the file this morning. So, but it was essentially just some code. This is the other Lambda function. This here is the Lambda function that pulls in from the Dynamo DB onto the API. And it's pretty much just, it uses Boto 3. So for those of you who don't know, Boto 3 is a Python package that interacts with AWS. So you can use Boto 3 to interact with SSM parameters, secrets, or you want it to deploy a database. You can, Boto 3 is very, very versatile and you can use it for anything. But I probably would not advise you to use Boto 3 to be deploying databases. You should leave that for some other infrastructure as code. Boto 3 is pretty much a Python package to interact with AWS resources. So going back, that should have finished. Yay, successful. Right, so I'm going to go to the Dynamo DB and you'll see that the data should have populated. Tables, explore items. Yeah, so the data started to populate. I did it in, I put some date, I put a date time here, date, and you can see for the different countries, the data has been populated. And that Lambda will pretty much run every 1 minute and start populating this table. Now we should take care of the other Lambda. So there's only 3 other things left to do, is to paste the code into the other Lambda, create the API gateway, and upload the S3 bucket code. And we should see a function with just a graph. So this Lambda will pretty much pull from the Dynamo DB, copy paste that code. So is this code here. Press deploy, so the changes are implemented, and we can test it. Oh, we can pick any event is fine. Let's call this test. Test. And that Lambda returns data. Lovely. Okay, so we created a Lambda that returns data. Now we need to front that with an API gateway so we can access that Lambda, trigger that Lambda, pull the data into the API. So let's do that. Head over to API gateway. Let's create a REST API. Going to create a new API. We'll call this, actually, that's probably fine, interconnector API. Make it edge optimized. Now we've created the API, but we've not created any methods. So I'm going to create a method, create method, and I'm going to create a get method. That get method, I'm going to link it to the Lambda that we just tried earlier. For the purpose of this workshop, I'm going to enable cross origin resource. I don't know what the S stands for, I've forgotten. And deploy. Let's call this stage. Sometimes you'll see V1, V2 in APIs. We'll just call this one V1, version 1. I'm going to copy paste this. Note that I didn't add any security to this, no authentication or anything. So if I just paste this into a browser, you'll get the data back. So you've now created an API. You've created the infrastructure of the backend that's pulling in data, polling another API, putting it into your own database, doing your own manipulations. And now you've got an API which you can access or hit. Now, the final piece of the puzzle is the code in the S3 bucket. The S3 bucket is empty at the moment. This is the S3 bucket, Brighton Pi. Yep, that's correct. And I'm going to upload the code into here. I'm just going to drag and drop. AWS is a little bit funny sometimes. If you press add files, you can't add folders. If you add folders, you can't add files. So the best thing you need to do is to drag and drop. Oh, hold on. This is just a React build. So it's just using chart.js, and it's just a chart, and it will pull that API so that it can output it onto a screen. Looks like that succeeded. So we're going to head over to CloudFront. Bearing in mind that I didn't do anything to link the API link with the front end code. There's a few ways you could do that. I mean, you could put it in directly if you like, or you could create a domain name and then have it refer to the domain name. But for the purpose of this, I've left it blank and actually kept it as an input. So this here is the link to the CloudFront link. So that fronts the application in front of the S3 bucket. It's not got a domain name. That's why it looks funny. But we can add a domain name and map it. But this is all it is. Like I said earlier, I didn't do anything with the API link. I've just left it as an input. So then it's the easiest way to do it and show you as a front. So I'm just going to paste it into here. Click generate. I think there's a 5-second delay, but yeah. So now you've got a front end screen. It will keep polling. So it will call the API, and that API will activate Lambda every single time and then pull back data from the Dynamo DB. In the meantime, the other Lambda is also taking in data and doing its own manipulations. So just a recap. If you ever want to do this workshop on your own, by the way, I did create a document for Hack Sussex, so the university students at Hack Sussex, and it's pretty much got a step-by-step on here. Although the link to the drive with all the files have gone down, I will update it with another link. But just as a summary, what have we done? We have used infrastructure as code, and we've deployed pretty much the bare bones. Then we've added the API gateway, added the code in here, and added the code in here, which they all can be automated with infrastructure as code and with some sort of CI/CD pipeline like GitHub Actions or code build or code pipeline. It can all be automated with all these relationships between each tool. A lot of the tools we have at EDF are just upload to GitHub and it's deployed. So that's how we operate within wholesale market services. But that's it for me. I'm going to leave this QR code up here. It's the careers page in case you ever want to work for us. But yeah, cool.